Okay, let's take a look at some things that we can do with matrices. So in Algebra 2, we learned how to solve systems of 3 by 3 equations using the elimination method. I had a graphic organizer that some of you use that help you choose the equation, what to multiply, what to eliminate, one variable at a time. Now we're going to do the same idea, except we're going to use matrices to solve 3 by 3 systems of equations. And today it's just going to be a little background and information on how you do certain things with matrix operations and things like that to help us. So the first thing that we are going to look at is how we can take a 3 by 3 system of equations, like what is written here, and make it into an augmented matrix. Okay, basically that just takes the coefficients of each equation and makes it a row in the matrix. Okay, so what that means is we've got this system here, okay, where we have, oops, there we go. Here would be our row 1, row 2, row 3, and across the top we'd have here's column 1, column 2, column 3, and column 4. And what we're going to do is we're just going to make ourselves a 3 by 3 matrix. So we're going to have 3 rows and 4 columns. So what we're going to do is we are going to take the coefficient of each, and we are going to put those in our row. Okay, so row 1 is going to be 1, 3, -1, and 9. Row 2 is going to be -1, 4, 2, and -2. And then row 3 is going to be 1, -3, -6, and 5. And quite often what I like to do is to separate the X, Y, and Z columns, like this is our X, our Y, our Z. I like to put a little dashed line right here so we know the difference between, those are our variables on the left 3 columns, and then their solutions are on the right. Okay, so let's take a look at some of the things that we can do with these augmented matrices, excuse me. The 3 things that we're going to talk about today is you can, first of all, interchange 2 rows. All that really means is that you can flip-flop row 1 and row 2 or anything like that, and it still makes the same matrix. The second thing, you are going to multiply an equation by a non-zero constant. All that means is you're going to pick a row, and you are going to multiply everything in that row by a certain number. Okay? And then the third thing is you can add a multiple of an equation to another equation. We are going to do quite a bit of that, where basically you multiply an equation by a number, and you add it to another equation or another row. So let's kind of just take a look at how this is going to work. So the first thing, interchange 2 rows, like that's the first one on our list. So this example says we are going to swap row 1 and row 2. All that means is that we are going to take row 1 and row 2, and we are going to flip-flop them. So in our new matrix, and again, we can put them in our brackets, and our row 1 and row 2 are going to flip. So now I'm going to have -1, 2, 0, 3. That was our original row 2. Now it's our row 1. 0, 1, 3, 4. And then our third row doesn't change at all. Like so. Okay, so that's one thing that we can do. We don't do that a ton with solving our systems, but it is helpful to do sometimes, so we might need to use that. The second thing was to multiply an equation by a non-zero constant. That would look like this. Okay, a non-zero, we have a half. You could multiply it by a positive number, a negative number, a fraction, a decimal, anything that you want. And basically what this symbolism here means is this right here tells us what we are doing, or what I'm doing. Okay, and this over here tells me where it goes. Okay, and this over here is the only row that changes from the old matrix to the new matrix. Okay, so if we are going to take half of row 2 and put it in row 2, I always like to show all my work kind of in between the 2 matrices. So we are going to take half of row 2 and put it in to row 2. And again, row 2 is the only row that's going to change. So half of row 2 would be this row right here. We're going to take half of it, so negative 1/2. 2/2 is just 1. 0 over 2 is still just 0. And then half of 3 is 3/2. So what we're going to end up with is this is going to be our new row 2, and everything else just stays the same. Okay, so the 0, 1, 3, 4 stays the same. Our new row 2 is negative 1/2, 1, 0, 3/2, and then our bottom row stays the same, 2, negative 3, 4, and 1. Okay, so that's just multiplying a row by a number. It can be positive, negative, whole number, fraction, decimal, whatever we want it to be, that will help us with what we need. Okay, and then we are going to take a multiple of a row and add it to another row. So basically we are going to multiply row 2 by 3, add it to row 3, and put it in row 3. So this is what I'm doing, and this is where it's going. And again, row 3 is the only row that changes. I keep saying that as much as I can because there are so many little places to get confused and lose track of numbers and things like that. So I'm going to write here in between my original matrix and my new matrix, this is what I'm doing. I'm taking 3 times row 2, and I'm adding it to row 3, and I'm putting it in row 3. Okay, so then I'm going to show what I'm doing. I'm taking 3 times row 2. So here's my row 2. I'm taking it times 3. So that's going to be negative 3, 6, 0, 9. And I'm going to add it to row 3. This is row 3. I'm going to add it to 2, negative 3, 4, and 1. And when I add them together, it's not like adding where you carry the 1 or anything like that. Each column of your matrix is going to have, it doesn't matter how big the numbers are in there. So we're going to have negative 1, 3, 4, and 10. So again, row 3 is now, that's going to be our new row 3. Everything else just copy paste, stays the same. Row 1 and row 2 don't change. 0, 1, 3, 4, 1, negative 1, 2, 0, 3. Those two stay the same. Row 3, which is our new one, is the only one that changes. Negative 1, 3, 4, and 10. Okay, let's just keep looking at a couple more here. Okay, just some more operations here. I'm going to take row 2 plus row 1 and put it in row 1. So here's what I'm doing. I'm going to take, again, I'm going to write it down here. I'm going to take row 2 plus row 1 and put it in row 1. Row 2 is negative 1, 2, 0, 3. Row 1 is 0, 1, 3, 4. When I add them together, I get negative 1, 3, 3, 7. So that's going to be, this is going to be my new row 1. So my row 1 has changed. Now it's negative 1, 3, 3, 7. And then row 2 and 3 stay the same. Negative 1, 2, 0, 3, 2, negative 3, 4, and 1. Okay, so let's just try another one here. Okay, we're going to take negative 2 times row 1. We're going to add it to row 2, and we are going to put it into row 2. So let's take negative 2 times row 1. So we're going to have 0, negative 2, negative 6, negative 8. Add it to row 2, which is negative 1, 2, 0, 3. We add them together, and we get negative 1, 0, negative 6, negative 5. So our new matrix, again, row 2 is the only row that changes. So our row 1 stays the same. So we're going to have 0, 1, 3, 4. Row 2 changes to what we calculated down here, negative 1, 0, negative 6, negative 5. And then row 3 stays the same, 2, negative 3, 4, and 1. Okay, so that's an example of how you can do different operations and different row operations and things like that. Now, we actually do the homework and figure out how to actually solve these 3 by 3 systems with matrices, I am not going to give you this information where it says multiply -2 times row 1 plus row 2. Those are the things that you are going to have to figure out. So this next part here says, what would I need to do if I wanted to get a 0 in row 3, column 1? Well, row 3, column 1 is right there. Okay, that's the bottom left-hand corner. And when we start solving tomorrow, that's where we're going to start every time. We're going to want a 0 in that lower left-hand corner. So that means I need to think, all right, I need to get a 0 there. So I need to think, what two rows am I going to use where I can multiply one of those rows by a number and end up adding them together to get a 0. Okay, so what that means is I am going to take my row 2 right here, and if I multiply it by 2, so if I take 2 times row 2, okay, and I add it to row 3 and put it in row 3, that will give me a 0 where I want it. So let's actually see how that works, okay? So we are going to take 2 times row 2. So that's going to be a -2, 4, 4, 6. That's 2 times row 2. And then we're going to add it to row 3, which is 2, -3, 4, and 1. So that gives us the 0 where we wanted it, 1, 8, 7. So that gave us the 0 in that first column over there. Okay, so our new matrix, again, the only row that's going to change is row 3. So 0, 1, 3, 4 stays the same. -1, 2, 2, 3 stays the same. Our only row that changes is row 3, and now we have a 0 in that lower left-hand corner, which is what we want. Okay, so let's try that kind of logical thinking again. What would I need to do if I wanted to get a 0 in row 3, column 2? So I want a 0 here, okay? Or maybe if I highlight it, I want a 0 there. So I need to pick 2 equations. Basically, I need that column to have a +3 and a -3, okay? So I am going to take, okay, I'm going to take row 1, and I'm going to multiply it by 3. What that does is gives me a 3 in that position there, so when I add them together, I get 0. So I'm going to take 3 times row 1, and I'm going to add it to row 3. And where do I want that 0? I want it in row 3, so I'm going to put my result in row 3. So if I take 3 times row 1, that's going to be 0, 3, 9, 12. I'm going to add it to row 3, which is 2, -3, 4, and 1. When I add them together, I get 2, 0, 13, 13. I wanted to get, my goal was to get a 0 here, which I did. That's my new row 3. And now I can just rewrite row 1, 0, 1, 3, 4. I can rewrite row 2, -1, 2, 2, 3. And my new row 3 is 2, 0, 13, 13. And I have a 0 where I want it to be. So tomorrow we are going to take these ideas and we are going to implement them into solving 3 by 3 systems of equations.